Welcome to this tutorial on creating sequences with NumPy arange. In this video, you'll learn how to generate arithmetic sequences using one of NumPy's most fundamental functions. This is an essential skill for numerical computing and data manipulation in Python. NumPy arange is a function that creates NumPy arrays containing evenly spaced values within a specified interval. Think of it as similar to Python's built-in range function, but with a key difference. While range returns a range object, arange returns a NumPy array. This makes it much more powerful for mathematical operations and scientific computing. The basic syntax of arange takes three parameters. First is start, which is the starting value and is inclusive, meaning it will be included in the output. Second is stop, which is the ending value and is exclusive, meaning it will not be included. Third is step, which defines the spacing between consecutive values in the sequence. Let's start with a simple example. When you call arange with just a single argument, like arange of 10, it creates an array starting from 0 up to, but not including, 10. The output is an array containing the integers 0 through 9. Notice how the stop value of 10 is not included in the result. You can customize both the start and stop values. In this example, arange of 5, 15 creates an array that starts at 5 and goes up to, but not including, 15. The output contains the integers from 5 through 14. This is useful when you need a sequence that doesn't start from 0. The step parameter controls the spacing between values. Here, arange of 0, 20, 3 creates an array starting at 0, going up to but not including 20 with a step of 3. The output shows 0, 3, 6, 9, 12, 15, and 18. Each value is 3 units apart from the previous one. NumPy arange also works with floating point numbers. In this example, arange of 0, 1, 0.2 creates an array with decimal values. The output shows 0.0, 0.2, 0.4, 0.6, and 0.8. This is particularly useful for creating sequences with fractional increments. Let's review the key points. First, the stop value is always exclusive and never appears in the output. Second, arange works with both integers and floating point numbers. Third, it's more efficient than Python lists for numerical operations because it leverages NumPy's optimized array operations. Finally, if you don't specify a step value, it defaults to 1. These concepts form the foundation for creating numerical sequences in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.